Welcome to multiplication and elimination. Yesterday you guys saw elimination and the basics of it, and it really stemmed from the following idea. If I wrote the equation 1 plus 3 equals 4, you guys agreed that was true, and 2 plus 6 equals 8, you guys agreed that was true. I then asked you to consider what happens if I add them together vertically. 1 plus 2 equals 3, 3 plus 6 equals 9, and 4 plus 8 equals 12. And then you guys were like, yeah, 3 plus 9 equals 12. So that proved to us that we could add two equations to make a true statement. And then what we did yesterday is we used that idea to add two equations to eliminate a variable so that we could solve for that one other variable and then back solve for the solution to a system. And so today we're going to unite elimination with multiplication to solve more advanced systems. And so the one thing I'd like to ask you before we move on to examples is the following question. So if I asked you, do you agree that 1 plus 2 equals 3? If you weren't being difficult, you'd say yeah. And then my question becomes, what if I multiply every term by the same number? So let's say I write this equation again, but I multiply every number by, let's say, 2. So I do 2 times 1, 2 times 2, and 2 times 3. I want to know, does 2, which is 2 times 1, plus 4, 2 times 2, equal 6? And you would say yes. So if I multiply a true statement by the same number in each term, I create another true statement, and that's what we're going to use to solve systems where we don't have the coefficients on variables or opposites to begin, so that we can get the coefficients to be opposites and then actually solve the system. So now go ahead and open the flap to the first system. The first system that you should see for today's notes anyway is x minus 2y equals 10, and then negative 24x plus 4y equals 24. And if you look at them how they are, we have 1x here, and you should notice that the 1x and negative 24x, if I tried to add them together as they are, they do not cancel. If I look at the y terms and I look at negative 2y and 4y, they do not cancel as they are. And so what we'll need to do is pick a variable, and in our two examples today, you can pick either variable, it'll work, and choose that variable to eliminate, and then the goal becomes, what do we need to make the variable's coefficients so that they do eliminate? So let's look at it more concretely. Let's say I wanted to get rid of the x's. In order for them to eliminate when added together, I would need them to be opposites. So the 1x would really need to be 24x in order for the two to cancel out when added together. But to get 1 to 24, I would have to multiply 1 by 24, which means that from the previous page, I'd have to multiply the negative 2y times 24 and the 10 by 24 to make sure that I have true statements. Let's look at the y's. So let's say I wanted to eliminate the y variable. Then I would have negative 2y and 4y to look at. I do have opposite signs already, so I just need to get the 2 to be a 4. And hopefully you guys see I would need to multiply 2 by 2 to get 4. And so not only do I need to multiply the 2 to the negative 2y, but I also need to multiply it to the 1x, and I need to multiply it to the 10. I'm going to go ahead and stick with eliminating y's. You guys could do the x's. We will get to the same place. And so from here, I'm going to keep the second equation true, and I'm going to rewrite the first equation when I multiply it by 2. So 2 times 1x is 2x, negative 2y times 2 is negative 4y, and the 2 times the 10 on the right-hand side of the equation every term equals 20. And from here, I can go ahead and add two equations to see if I can now cancel out the variable. So if I focus on the start equation and then this new equation that I got, I get that the y's will cancel out, and I'll get negative 24x plus 2x is negative 22x, and I'll get 24 plus 20 is 44, and I'll need to divide by negative 22, and I'll get x equals negative 2. And so now we'll go ahead and back solve and make sure that we've identified the correct solution. Please be sure that when you do the back solve, you are going to use one of the original equations, and then for the test, you're going to use one of the other original equations. So for example, I'm going to usually use the first equation for the back solve, so not the multiplied equation, just in case something happened to make that equation incorrect. I'm going to use x minus 2y equals 10, and then the second equation, negative 24x plus 4y equals 24. So I use the first equation for the back solve, the second equation for the test. And then from here, it's just plugging in and solving. So I'm going to substitute in the x for negative 2, and I'll get negative 2 minus 2y equals 10. Got to solve my two-step and isolate the variable term. I get negative 2y equals 12. And if I divide both sides by negative 2, I get y equals negative 6. So I'm proposing that the solution to this system is negative 2, comma, negative 6. And I want to test that. So I have x comma y. I'm going to plug in the x is negative 2. So negative 24 times x is negative 24 times negative 2. And then plus 4y is 4 times negative 6. And I want to see, does that equal 24? And so if I simplify left to right, I get positive 48. I get negative 24. And I want to see, does that equal 24? And indeed, if I combine those terms, I get 24 equals 24. So I know I've solved the system correctly. So if you look at the opposite side and you look at the second row, you should see our final example for systems. If you'd like to try it on your own, go ahead and try it and then check in with me in this video to make sure you've done it correctly. Otherwise, go ahead and keep watching. Here's the final system for today's notes. 2x plus 2y equals 24, negative 6x minus 1y really equals 8. If you notice straight away, the 2x and the negative 6x will not cancel. The negative 1y and the 2y will not cancel. If I wanted to eliminate the y's, for example, I would want the negative 1y to become negative 2y, which means I'd have to multiply the 2 to the negative 6, the 2 to the 1, and the 2 to the 8. But let's say that for this example, I'm going to go ahead and get rid of my x's. So I want the 2x and the negative 6x to cancel. Well, I would need the 2 to become a 6. But in order to get 2 to 6, I need to multiply 2 by 3. Not only am I going to multiply the 3 to the 2x, but I'm going to multiply the 3 to the 2y and the 3 to the 24. So my second equation stays the same, but my new equation will be 6x plus 6y equals 72. And now I'll go ahead and solve the system using these two equations. If I add vertically, I get that the negative 6x and 6x cancel. 6y and negative 1y is 5y equals 72 plus 8 is 80. Divide both sides by 5, and I get that y equals 16. From here, I'm going to go ahead and do the same as with the last example and write one equation for the back solve and one for the test to make sure that I'm guaranteeing whatever I get for my solution is a solution to both the first equation and the second equation, which then comprises the system. And from here, we need to figure out what the x is. So 2x plus 2, I got my y to be 16, equals 24. Simplifying, 2x plus 32 equals 24. If I subtract 32 from both sides, 2x equals negative 8. Divide by 2, I get x equals negative 4. And so careful writing your solution as an x comma y. But if I do write it as an x comma y, I'm thinking that it's going to be negative 4 comma 16. And let's verify that by plugging it into the other equation for the test. So negative 6x becomes negative 6 times negative 4 minus 16 and then equals 8. Negative 6 times negative 4 is 24 minus the 16. Does that equal 8? And I do get that 8 equals 8, and so I've solved my system correctly and gotten the correct solution to the system that makes both equations true. From here, I'd like for you to finish this example, show your completed notes to the teacher so that you can get the practice assignment to follow this up independently.